Within two-sample hypothesis testing, we can also calculate the confidence interval. In this example, we're going to calculate the confidence interval when the variance is assumed equal. In this example, we're looking at a special bumper that was installed on selected vehicles in a large fleet. The dollar cost of body repairs was recorded for all vehicles that were involved in accidents over a one-year period. Those with the special bumper are the test group, and the other vehicles are considered the control group. Each repair incident is defined as an invoice, which might include more than one separate type of damage. We're going to construct a 90% confidence interval for the true difference of the means, assuming equal variances. So we're going to start by looking at some of the information. Let's assume we know the average for the first group is 1,101. The standard deviation is 696. The sample size is 12. And then for sample 2, we're going to assume an average of 1,766, a standard deviation of 838, and a sample size of 9. For our alpha value, since we're looking at a 90% confidence interval, we'll have an alpha value of 0.1. And then our t value would equate to 1.664. So we would know that given the value of our alpha value. Our degrees of freedom would be calculated as our sample size for the first group and the sample size for the second group, each of those minus 1. So that would be 12 minus 1 plus 9 minus 1, or a value of 19. Our t-critical calculation would be calculated as t dot inverse and two-tailed, since it's a two-tailed test, using our alpha value of 0.1 and our degrees of freedom of 19. So our t-critical value would be 1.7291. Our confidence interval would be our value of B10, our x bar from sample 1, minus our x bar from sample 2. So we have a value of 665, and we take the absolute value because one might be larger than the other when we subtract. And then our calculation for the plus or minus portion would be B14, our t value, times the square root of B12, so our sample size of 1 minus, our sample size from sample 1 minus 1, plus our B11, which is our standard deviation squared to get our variance, plus E12, which is our sample size from sample 2, minus 1, times E11, our standard deviation squared to give us our variance, divided by B12, our sample size of 1, plus E12, our sample size from sample 2, minus 2, multiplied by the square root of 1 over B12, our sample size, plus 1 over E12, our sample size from sample 2. So that gives us a value of 556.94. So our interval then would be our average minus that second portion of the equation up to our average plus that second portion of the equation as well too. So our 90% confidence interval for the price would be between $108 and $1,221.95.